This is Bob Capetta from the University of Illinois at Chicago, and this is another example of integration by parts. We're going to look at the integral of 4x squared cos 3x dx. So we have to decide what is u and what is dv. And in both cases, these are easy to differentiate and easy to integrate. When that happens, make sure you're not making something more complicated by integrating it. If I integrate 4x squared, I get 4x cubed over 3. That makes it more complicated. So therefore, we're going to let u be 4x squared and dv be cos 3x dx. Now I've got to find du and I have to find v. So let's go through our usual process. The derivative with respect to x of u is the derivative with respect to x of 4x squared. So du dx is 8x. And du is 8x dx. Over on the right side, we're going to take the integral of dv as the integral of cos 3x dx. Now how do we do that? To do the integral of cos 3x dx, I need to do a substitution. So we're going to let u or w be 3x and then go through the process of doing this integral. So indeed, I'm going to let w equal 3x. And we're going to substitute for dx here using our w substitution approach. The derivative with respect to x of w is the derivative with respect to x of 3x. So dw dx is 3, dw is 3 dx, and in the case of w substitution, I like to solve for dx. We're going to say dw divided by 3 is equal to dx. So coming back up to this first line, the integral of dv is the integral of cos 3x dx. Cos 3x will become cos w, and dx will become dw divided by 3. The integral of dv, of course, is just v. That dw divided by 3 is really 1/3 dw. 1/3 comes out in front. V is 1/3 the integral of cos w dw. Integral of cos w is sine w, so we get 1/3 sine w plus c normally, but as you know, that's not important for us in this integration by parts strategy. So I have u is 4x squared, du is 8x dx, dv is cos 3x dx, and v is 1/3 sine w, and of course we need to rewrite that. How? As 1/3 sine 3x. So we have all our pieces, u du, dv, and v. 1, 2, 3, 4. We're going to use those 4 pieces to rewrite this using integration by parts. So those are the bits of information we need for this. Our formula is integral of u dv is uv minus the integral of v du. Integral of u dv, integral of 4x squared cos 3x dx is uv, 4x squared times 1/3 sine 3x, minus the integral of v du, minus the integral of 1/3 sine 3x times 8x dx. Now, can we simplify this? 4 times 1/3 is 4/3. So how about 4/3 x squared sine 3x? 1/3 times 8 is 8/3, which I'm actually going to leave on the right side of the integral. So 8/3 x sine 3x is where we are now. So as you can see, we have another integral we have to do. And to do that integral, we are again going to have to do integration by parts. Then we're going to plug that in to go ahead and get our final results. So here's where we are. I want to focus on that integral of 8/3 x sine 3x dx. We need a u and we need a dv. I'm going to use my u of 8/3 x. When I take its derivative, it's just 8/3. It's getting simpler. My dv will be sine 3x dx. Usual strategy. The derivative with respect to x of u is the derivative with respect to x of 8/3 x. So du dx is 8/3. And in the case of integration by parts, we need u and du, so du is 8/3 dx. We get that for free. Now to get v, we have to integrate sine 3x. So the integral of dv is the integral of sine 3x dx. And to do this, again, we're going to need a w substitution. But the fact is, we did that on the previous page. We have w is 3x, dw dx is 3, dw is 3 dx, dw divided by 3 is dx. It is the same change of variable that we did on the previous slide. So then the integral of dv is v. This will be the integral of sine w. Dx is dw divided by 3. Pulling the 1/3 out in front, we get v is 1/3 integral of sine w dw. Integral of sine w, that would be negative cos w. So we get v is 1/3 negative cos w. What is w? W is 3x. So v will be negative 1/3 cos 3x. So we have u du, dv, and v. We have everything we need to do this integral. Once we have that integral done, we're going to substitute it back up here to get our answer for our original integral. There's our original integral. This is the integral we're working on u du, dv, and v. Of course, integral of u dv is uv minus the integral of v du. Integral of u dv, integral of 8/3 x, sine 3x dx is uv 8/3 x times negative 1/3 cos 3x minus the integral of v du minus the integral of negative 1/3 cos 3x times 8/3 dx. And you'll notice that the algebra and arithmetic gets challenging. Looking at this first bit, 8/3 times negative 1/3 is negative 8/9. So we get negative 8/9 x cos 3x. Over on this side, we get negative 8/9 cos 3x as well. And if we pull that out in front, you'll see how the sign's going to change. Again, negative 8/9 x cos 3x, negative 8/9 cos 3x. Where do we go next? Again, there's the integral we want to do, our original integral. Here's this piece that we're going to substitute. This negative 8/9 moving out in front minus negative 8/9 will become positive 8/9. And to do this, we're going to need to use a w substitution, the same two w's that we had earlier in the problem. So it looks like I'm actually leaving the negative 8/9 in there, which is fine. So cos w dx is dw over 3. Now we have negative 8 over 27 cos w dw. Minus negative 8/27 becomes plus 8/27. Integral of cos w is sine w plus c, but again, we're not worrying about the plus c here. And our w is 3x. So we get negative 8/9 cos 3x plus 8/27 sine 3x. Indeed, we will need the plus c at the back end of this final problem. So this whole piece has to get substituted in for this integral. My advice is put it in brackets and be sure to distribute that negative sign correctly. So again, here's our question we're working off of. We've done this integral. We're going to substitute in that integral. Here it is, negative 8/9 x cos 3x plus 8/27 sine 3x plus c will go in for this integral. So we'll get 4/3 x squared sine 3x minus brackets all of that. Now there's only one last thing to do. I have to distribute this negative sign. Minus negative 8/9 will become plus 8/9. Minus 8/27 will become minus 8/27. Minus c, you could argue that's minus c, but of course subtracting an arbitrary constant is equivalent to adding an arbitrary constant. So there's no reason for us to change that. And we have a solution. But notice it required a lot of arithmetic, a lot of algebra, and it required integration by parts twice. So you just got to be very, very careful with things like negative signs and fraction multiplication. And if you do so, you can get a challenging problem like this correct. And that will end this lesson.